My name is Andrzej Rościszewski. I'm a senior investment associate at Expeditions. Expeditions is a 200 million euros early stage fund that is investing in defense first and security companies across Europe. Without further ado, I would like to present the topic, which is drone and aerial defense. My job is quite easy, actually, because 20 minutes ago we had presentations from Balázs from Titan, and he probably mentioned most of the problems that are associated with this topic. I would like just to leave you with a couple of things that are probably most important to remember during next 4 presentations, because the organizers of the conference did a fantastic job to bring 4 people with different backgrounds representing different companies that are actually trying to tackle the same problem, which comes from the proliferation of offensive systems. If we are looking at the statistics of how many attacks we are seeing in Ukraine using cheaper systems like Shahed drones and others, we can really easily understand what are the problems that are resulting directly from that. And we are talking about, first and foremost, the saturation of incumbent area defense systems that are just not able to track so many threats at once. We are talking about a second problem, which is a cost per kill problem. We can have a very capable effector like a Patriot missile, perhaps shooting a missile that is worth more than $1 million at a drone that is worth less than $20,000 is probably not a good long-term strategy. At the same time, you want to maintain a good success rate in terms of shooting those systems, because in the end they result in real loss in life and equipment. And the fourth problem is actually how to scale up the manufacturing of said effectors, and then finally how to close the kill chain in terms of coordinating 3 very different things, which are first and foremost detection, then tracking, and then neutralization of said threats. And if we keep in mind all of those 5 problems, and then we see the 4 presentations that will be presented right now, we can understand how different companies are trying to tackle the same problem, the same subsets of problems, but are coming from very different sides. And without further ado, I would like to invite Dirk Zimper from MBDA. MBDA is an incumbent prime, European prime that is specialized in missile systems, and of course they have quite a lot of products in the counter-UAS domain. So Dirk, please take the stage. And
hello, everybody. I'm glad that not everybody left the room already, and I'm glad that a few people are still sitting in the room. For you, I will make this interactive. And I hope that you will follow me just a little bit to keep this interacting. Before I will come to technology solutions, I wanted to bring a perspective into the room based on a topic that I investigated, I would say, just a few months ago. Whoever in this room dealt with innovation so far? Please raise your arm. So more or less everybody, and I hope for those who have not raised their arms, you have done it anyway. Who in this room have dealt with the word exnovation? Good. And this is not something, it is something that actually really does exist. And what I would like to do today is I will talk about exnovation and what it means. And I will try to use some historic examples for bringing the concept of exnovation into the room. Yes, please? I'm going to do that. So the question was if I can define the word exnovation. I'm going to do that based on historic examples. So, and before talking about exnovation, just bringing in my personal definition of innovation. Innovation is a service or a product established at the market and bringing a benefit to the end user. Sometimes people think an innovation is if you have a great idea. That's actually not the case. If it is established at the market, if it is a product or a service, then we're talking about innovation. But now let's talk about exnovation. Who has an idea what that woman here is doing? Exactly. She is a knocker-upper. That's Mary Smith. And that's actually a picture from the streets of London. And what she is doing, you know, some people in the room may think about their school time, but this is not the case. She's actually waking up people. Why? At that point in time, clocks were really expensive. So company hired knocker-uppers to put peace against the small windows to wake the people up, the workers, so that they can execute their work. So this service does not exist anymore today, for good reasons. Because actually the clock is affordable and everybody has it. Nobody would, you know, come to an idea to hire that service. Who knows what that is? It's a tape, it's a video cassette. I think everybody in the room knows it. Just side fact, before a few weeks, I had an internal workshop, and then I had a few students in the room. And then I asked them if they know what a videotape is. And then, you know, a guy raised his arm and said, I think he knows it from the context, but he has never seen it. So we all know how, or most of us in the room know how the videotape itself was replaced by a DVD. The DVD was bringing a new user experience to the people, and you had more content, you had director's cut, interviews with the actors. So it was a new experience for the user. It was a better quality. And then the companies studying DVD at that point in time, they took out the video cassette and they pushed the DVD into the market. From a user perspective, you think that's a natural evolution, but it wasn't. The companies did it. The companies working on the DVD did this on purpose for competition reasons, bringing a new experience to the user. And this is another type of innovation as well. Finally, I think this is difficult, but I will ask, any idea what that guy is doing there in front? I know that's difficult. This guy in front of the car is there for good reasons. In the UK, when the so-called powered vehicle entered the streets, there were a lot of people heading horses, and I thought, well, if that new technology comes into the market, then I really have an issue. And what they did is they established a law, the so-called Red Flag Act. And the Red Flag Act said, self-propelled vehicles are so dangerous, they are not allowed to drive faster than 6 kilometers per hour. And the guy, roughly 6 to 10 meters, have to run with a red flag in front of the vehicle to warn the people that there's a self-propelled car coming. Guess where most of the accidents happened? Exactly to that guy. You know, most of the cars just hit that guy in front, and there were so many accidents. And this law was in place for 30 years, from 1865 to 1895. Based on current studies, it's very clear that the big piece of car innovation in the UK was hindered by that law, because nobody invested in that technology due to the boundary conditions, right? And by nullifying the law and putting it out and then allowing investments, that's actually another type of exnovation. And now I'm coming to the asked definition. Exnovation is, at the end of the day, you are taking something that is not of use and does not make sense anymore, you take it out on purpose to allow room for new things. So it's somehow the opposite of innovation, but in a good way. When you think about it, real exnovation allows innovation. Because you think about, okay, how can I do it differently if I take this out? Does that law make sense? No, take it out. And just a matter of fact, a question into the room, what do you think is the ratio between new established laws in Germany and nullified laws? What is the ratio? Any idea? It's 10 to 1. It is 10 to 1. Something to think about. So now, what does that mean within the context of air defense? And that's something I did within our company. I asked them, okay, what is if the solution would look different from what we have done it in the past? One example. At one point in time, our guys came and said, well, we have a weapon that is based ground to ground. What is if we take all the unnecessary technology out and just put something on to defend against drones? Such a simple question, but that's something we did. We took the so-called Enforcer, which is a ground weapon, So we left the guidance, the control, we left the engine and said, okay, we'll just put a different sensor on it and then shoot it in the air so that it can defend against the drone. And actually, it does work. It was a type of exnovation where you exnovate a subsystem technology to give another application. And then I asked my people, and we are a company, we are producing missile systems. And then I asked my people, so what if the solution is not a missile? They were looking at me, well, what? Again? I said, what if the solution is not a missile? Let's think about something totally different when we have to defend against a drone. And then another type of idea came up, why not using a high-energy laser weapon system? I can tell you today, after almost 10 years of research in that technology, we have now reached a stage where we can switch from just pure technology into operational systems. We have, and this is not future anymore, we have laser weapon systems being able to defend against drones. Sometimes I'm asked if that is the game-changing technology. No. In military, there is no game-changing weapon system. It's always good if we have very, very opportunities. And the laser weapon system is just bringing in another opportunity to defend against drones. And then another very urgent topic. Most of you have heard about the threats about hypersonic weapon systems. The Kinjal was used in Ukraine. From my perspective, it is not a hypersonic weapon system per definition because it's not maneuverable. The real hypersonic offensive weapon systems, the real threat they cause is they are maneuverable and for that reason not predictable anymore. A ballistic missile is very easy predictable because it just flies a ballistic trajectory, which is not the case for a hypersonic weapon system. And then you have to think about, okay, how should my interceptor look like and what can I make in a different way to allow long range, various portfolio. And then our guys came up and said, well, let's assume you do not have just a solid motor that you usually use when you go extra-atmospheric or when you go in the atmosphere at that altitude beyond 50 kilometers. What is if we use an air-breathing engine that is throttleable? That's what we can see here. It's an interceptor with a so-called ramjet engine. It's an air-breathing engine taking the oxygen out of the air, which means you can put more energy into the rocket motor because you do not need to put the oxidizer into the motor itself. You take it out of the air and you increase greater performance. So and all these things were just some examples where we exnovated something out and it left the room open for innovation. And what I would like to say today is I would like to leave that concept in the room because I personally think that this is really a driver for innovation. If you think about, okay, how can we do it in a different way? That's a question you would always ask. But if you say, okay, we take this out. Not only technologies, but also processes. We take that out. Specific things that are not of use or does not make sense anymore in these days, we take it out of the equation. And look what is left. And how we can replace this. And finally, I would like to leave with that statement. And I personally think this is true. Those who focus solely on innovation will remain in the game. Those who master exnovation will rewrite the rules of the game. And I would like to leave 2 questions in the room. When was the last time you did something for the first time? And secondly, when was the last time you really did something for the last time? Thank you.
Thank you so much, Dirk. Now I invite Carl Brew from Takava. Takava is a Portuguese-born but very much UK-based drone company. And Carl, apart from talking about Takava, your perspective of moving from the servant perspective to a startup perspective, that would be very interesting. Thank you so much.
Thank you very much. Good morning. So I'm here today to talk about Takava and our journey when it comes to helping speed up adoption of autonomy into defense. Takava is a little bit different from, I think, some of the other companies you heard about, 2 years old, 4 years old, but we've been around for quite a while. We were founded in 2001 in Portugal, and we really went through the true scars of trying to take a company from startup to scale up, but at a time when, to be honest, the market wasn't ready. By 2011, we started as a software company, and we tried to bring that core idea of hardware-defined software to the market at a time which was where drones were dominated by aerospace. And we approached the large aerospace companies and said, hey, we've got a great idea. We can help speed this up, speed up iteration cycles. And we were told to go away. This was a different time. So we decided to try and do it ourselves. And we went into hardware. We went into the principles of vertical integration. And by 2015, we had a number of viable systems. And we were focusing at the time on intelligence as a service. But we almost failed. The market wasn't there. The regulatory environment wasn't there. And we were very lucky to then escape that valley of death and reach the position we are today, largely defined by our involvement in Ukraine, which is and ever-changing technology cycles, which is essentially really boosted us on our journey. So the core idea I want to promote today is that when it comes to a market in defense, which is defined by increasingly fast technology cycles, we need a different type of company. And that's about how you build and optimize a company. There is a reason traditional prime companies are built and optimized in a certain way. And our core idea is, if we are to be successful in this space, we have to optimize the structure of the company differently. And that's what we're trying to do at TechEver. To start, though, it's worth going back to a key point in our history, which is essentially our involvement in Ukraine. We were one of the first companies to get involved in Ukraine in mid-2022. We saw it as a key part of our mission, that what could we do to help? We weren't a defense company. We were very much on the civil side of an autonomous systems company. And essentially what happened by summer 23, when we'd been active for about a year in Ukraine, the Ukrainians came to us with a problem. And this was the heart of why we set the company up. How do we solve difficult problems? And in Ukraine, we were very much the ISR guys, the deep ISR guys. And the problem the Ukrainians came to us with was a problem of an S-400. In summer 23, Ukrainians had two strategic problems. One, they were getting pressed in terms of the grain corridor from the Black Sea. Two, Ukrainian counteroffensive had just begun in the north here, and Russian flows of logistics was coming through Crimea. And the Ukrainians could tell there was an S-400, big Russian strategic air defense system, parked on the neck of Crimea near a place called Olenivka. But they had a problem. In order to target it, they had to find it and find that grid. And from commercial satellite imagery, they could find the locations where the Russians were essentially developing the infrastructure, but the system would move. They could find from electronic intelligence from overhead that you could find a general area, but you couldn't pinpoint its location. Coupled with that, we had perhaps one of the most complex air defense EW environments known to man. This was Crimea. This was the bastion. This was 2023. Mobile Starlink on light drones didn't exist yet. This was there was essentially Crimea was sacred ground for the Russians. Yeah, and for Ukraine, it was also about how a strategic shift could be created. And you see on the right here, complex multi-layered air defense system, things protecting the long-range air defense systems, complex EW. When we talk about EW, we often think, okay, no GNSS. But when you get into complex spoofing, you're talking how you can cause mechanical failure through the manipulation of GNSS signals. So super complicated problem. And this is what happened. This is footage from one of TechEver's platforms, an AR3, around 230 kilometers away from the ground control station. And as you see, Ukrainians who essentially had one shot were able to destroy the system. And this was a huge strategic shock. It echoed through the Russian system. Now, going back to the start, TechEver's not a defense company. TechEver's worked in defense for less than a year at this point. How does a company which isn't meant to be optimized for defense are able to deliver the strategic effect through partnerships with the Ukrainians? This is the core question. And before we get to that, it's worth just retouching on the defense industrial problem. And a lot of companies have spoke at length of this today already, but I just want to echo a few points. It's naive to think there's good and bad companies, right? It's just a problem of how companies optimize. Primes are amazing companies. They do amazing engineering. But they are optimized for a model that has become outdated. Prime models are based on cost-plus engineering, essentially, which came out of a consolidation of the Cold War. They are optimized for assurance, for long-term programs, and for investors, they're optimized for safe returns, for low-margin safe returns. And this was the model which we, from a both government and industry perspective, imposed upon them. But those traditional engineering models clearly do not work in fast-paced, iterative development cycles. But it isn't just about technology change. When we think about autonomy in defense, this is a system problem. To adopt autonomy isn't just about taking new, better kit. It's about how that will significantly impact force structures, force design, how to employ it. And it's a collective problem, not just one of technology. And this is super important. Ultimately, if we do not change, we don't have enough stuff. And it's as simple as that. Because, as I say in defense, the enemy gets a vote. And our adversaries are doing this. They're doing this now. And this is a real acute, urgent problem. So how do you solve this problem? For us at TechEver, it's about organizational design. It's about how do we, as a company, optimize ourselves to go faster, embrace technology sooner, still meet the compliance and challenging complexity of defense markets, and field that into the market at a pan-European level. And that's what we're doing. And I think if you break this down, there's kind of 4 key ingredients I would flag to how you get this right. And it's difficult. At the top, you essentially need not just access to capital, but you need the right kind of investors. You need investors who really agree with your mission. See, it's a long-term game. Right now, we have to make complex decisions about how we scale in a long-term vision, which if you were looking to flip your money in 2-3 years, you wouldn't make. So it's really important. We've been very fortunate in our partners that we, and Bailey Gifford and NATO Investment Fund and UK Street Investment Fund up there, just as some examples, everyone shares that long-term vision, because that enables us to invest upstream. And this was mentioned before, but for us, understanding what the market needs and investing upstream is critically important. We could just point at government and say, well, you need to give the demand signal sooner and put this down the chain, but that's not going to happen. So there's 2 sides of responsibility to this. The second thing we need is essentially a different model of customer integration. And this has been absolutely proven in Ukraine. And the reason we need that is essentially it's a challenge of requirements trading. If you look at, okay, how do you, if you looked at a traditional capability model and said, how do I penetrate Russian air defense in Crimea, you would probably come up with a very highly complex, super stealth, advanced material composites, super expensive thing. But of course, there are trades. You can trade mass, cost effectiveness, survivability, speed, all these things happen in a trading and requirement cycle. And that doesn't traditionally happen in defense. Normally, it's requirement specification, off you go. And by building that system through deep end-user integration, it's critically important. But ultimately, what you really need is how do you design the organization? And this is the bit I struggle with on a day-to-day basis in TechEver, where we are trying to develop an organization. It's easier when you're small. We're 1,400 people on TechEver at the minute, even a couple of hundred. The nature of how people interact and work together, you can go fast. How do you do that at scale? How do you do that and comply to defense standards? And we are essentially leveraging a lot of different management theory. We're looking at what ASML is doing. We're looking at what Bayer's doing. How do you create organizations with limited hierarchy? How do you keep going fast as a small company? Really difficult challenge, but this is the heart of it. And finally, you need deep vertical integration. So a couple of pictures here. We bought an airport. Again, how do you look at that value chain? We need to test really quick. We've got to have access to airspace. What we invested in buying an airport. The bottom is our large manufacturing plant in Swindon, 250,000 square foot. How do we build to scale tomorrow? And this doesn't mean everything needs to be vertically integrated. This also comes with deep partnerships, because unless you can cascade your philosophy down your supply chain and drive that agility throughout, then you can't deliver. So in summary, if we're going to be successful in really leveraging autonomy into defense, I think we need different types of companies, and that's what we're trying to build at TechEver. Thank you. Cheers.
Thank you, Carl. And now I invite Jan-Hendrik Bollens from Alpine Ego. Jan-Hendrik is a CEO of Alpine Ego. It's a German-based counter-UAS company. Although Jan-Hendrik is Dutch. But of course, he was, before founding Alpine Ego, he was a CTO of Volocopter and Quantum Systems. And his flagship product, Sentinel, is deployed with the German Bundeswehr, and also participated in Vanaheim project in the UK, so a joint US and the UK capability assessment of counter-UAS products. Thank you.
So, thanks for the kind introduction, Andre. I need to make a correction, though. We're not a German counter-UAS company, we're a European company. That's something I insist on. Having said that, we're building a European counter-drone champion here. And as you see on the slide here, I haven't come to make a company presentation as such. I've come with a clear message to Berlin today. Guys, we are seriously fucked. That is not my statement. That is a sober... Maybe I'm being censored for using the wrong words. Can we get the mic back? Or... Sounds good. As I was saying, that is not just my statement. That is the sober assessment of a NATO battalion commander after his entire battalion was wiped out by a Ukrainian red team during an Estonian exercise recently. And unfortunately, that is not a singular data point. That is actually something that's a repeating pattern. We saw it 2 weeks ago, I think, in Sweden, the same thing happening again. So what this means is, after 4 years of full-scale conflict in Ukraine, the net result is that we are still not able to deal with this threat within NATO. Let that just sink in, what that means. We've had 4 years to prepare, and most of the militaries in the West haven't even started writing the doctrine, let alone procure the equipment to actually deal with this. So, rather than just telling you what Alpine Eagle does, I think this is the background of why it's important what we do, why really we need to provide the means to protect against this new threat. So, anyone that has read any piece of news during the last year, 2 years, will know about this issue. You know, it's been hiding in plain sight. We've had airports closed throughout Europe, in Germany, in Denmark, in my home country, the Netherlands, anywhere. We've had drone oversights of sensitive military installations like Ramstein Air Base, and a lot of the time, we don't even really know who is doing this. And I think that is the bit that most people don't get about drone warfare and about counter-drone operations. This is not just about, military operations in Ukraine and things changing on the front line. Do you remember the little green men that turned up in 2014 in Ukraine? They were unmarked. There was plausible deniability. It turns out that drones are the ultimate tool for kinetic hybrid warfare. You can launch strikes, even if there is not officially a war. Nobody will know who's operating these systems. Is it a state actor? Is it just an individual actor? Is it a terror organization? They're all made from the same Chinese parts. And so it's not necessarily traceable who's operating these things. That means that this is not a military problem. This is a societal, civilian problem. The fact that we're not seeing it everywhere yet doesn't mean that it isn't coming. The barrier to entry in this technology is far too low. This will unfortunately proliferate, and that means we need to start preparing for this. And I'm afraid it will only happen once something bad happens. This is the ultimate little green men that just turn up out of nowhere and nobody knows who they are. Now, I think you can guess the numbers behind this, so I'm not going to bore you with all the numbers. But surprising to me is that when recently the conflict in the Middle East started, essentially the conflict started on our terms, us being the West in that case. It started on our terms. And it should not have been a surprise that we were facing a large amount of shaheeds there, because Iran literally invented the shaheed. So we knew what was coming. Yet, after observing this for 4 years now, we were not adequately prepared to protect against this threat. So we are still in that situation where we are betting largely on these large, expensive systems that don't scale very well, that are not cost effective, whereas the other side has now learned to deploy cheap mass, really, very effectively, destroying capital assets quite easily. Maybe one way to think of that also here is essentially with the FPV drone, with the munition attached to it, we have essentially created a precision-guided long-range hand grenade. So I'd like to describe it. So whereas 30 years ago in Desert Storm, we saw laser-guided weapons for the first time, we were all in awe, at least I was as a little kid, seeing these things fly through windows, drop from fighter jets. That's now the capability that we give to each individual infantry soldier, essentially. They can do precision strike across 20 kilometers against an individual person. So each individual person, and I'm saying specifically not soldier, each person within 20 kilometers of the front line is essentially a target for precision airstrike now. That's the state of the technology. So, having set the stage as to why it is important what we do, where does Alpine Eagle come in? If you look at air defense, how air defense has evolved over, the last decades, there is a ground-based component. There are always going to be ground-based components strategically positioned around large strategic assets to protect them. Surface-to-air missiles, gun emplacements, what have you. But since the First World War, since the days of the Red Baron, essentially, there has always been an air power component to air defense, or more accurately put, air dominance. There's always been an aerial component to making sure we achieve air dominance. Aerial assets are flexible, rapidly deployable, can cover large distances, so they can actually be deployed with an offset. And you can't litter your whole geographic area just with interceptors on the ground. It's just economically impossible. So there is a need for an aerial component. We have started building this aerial component consisting of two elements. On the one hand, we have aerial sensing. Think of like a drone AWACS. And for those that are not familiar with that, AWACS is like the big radar planes that NATO deploys to do early detection in air defense. We are putting that on a drone, essentially, a mini AWACS, if you will, to provide early warning against incoming aerial threats. And then we also have the interception layer in the end. So air-launched interceptors, think of it like the drone version of a fighter jet, actually countering enemy drones. Thinking ahead, of course, think of that scaled up, times 1,000. If we're now seeing 1,000 enemy drones coming, we want to be able to deploy aerial counter-drone assets en masse as well. To show you what that can look like, I've brought a little video along as well. So that's the sensor and the effector platform taking off separately. So that is today. Let's imagine what this looks like in 5 years from now. And if that did not convince you that drone warfare is evolving, maybe think about the next steps. The last couple of years, drone warfare or counter-drone operations has always been about defending against flying drones. But increasingly, this is no longer a valid assumption. We are seeing in Ukraine ground-based drones, sea-based drones, UGVs and USVs, even undersea. So this is quickly turning into a multi-domain counter-drone operation. We are already seeing in Ukraine right now UGVs that are purposely built for countering UAVs. I'm making a bet that as the next thing we are going to see drones also, so flying drones, UAVs purposely built to actually take out UGVs or USVs. So increasingly, we have X by X as a matrix, essentially, a complete system. And what we are doing as Alpine Eagle, we're building the fabric to tie that all together, to build the system of systems and the software layer to be able to link all these sensors and effectors together and delivering a capability to the customer. We've already solved the hardest part, which is the airborne part. Now we're solving the rest as well. And to conclude on that, they asked for the room. I told in the beginning that we are seriously fucked, and that was, I think, a purposeful statement. What I would like to achieve is that in the next couple of years, if we ask this battalion commander, that he tells me that we unfucked his situation. So we solved the drone problem for him. And if you want to contribute to that, either as an investor or as a partner, or even as an employee in the team, I really look forward to speaking to you. Thank you.
Thank you, Jan-Henrik. Pleasure as always. I would like to invite Svilen from Dronamics. It's a Bulgarian company that is right now, if I'm not mistaken, please correct me, Svilen, but collaborating with Hensoldt on an early warning system, and we would all like to hear more about it.
Yeah, thank you. So, it's a pleasure to be here. My name is Svilen, like a villain with an S, but we're among the good guys. We started a company 12 years ago with a strictly commercial cargo aircraft. We felt this was a missing piece in the logistics ecosystem. You know, airplanes are too big, too expensive. They only fly between very big, very expensive airports. They get offloaded onto very big trucks. Let's create essentially a flying delivery van, right? So that was the scope. Obviously, this looks nothing like a van because we needed to go long range. We needed to be aerodynamic, fuel efficient, cost efficient. It needs to cost very little because Jeff Bezos has been teaching the world that shipping should be free for like 20, 30 years. Now, since we started, the world changed, right? And besides focusing on logistics, we're now also doing all other missions with regards to the broad spectrum of dual use, civil protection, national security, and defense. As well as we learned over these years how to design, to build, to operate ourselves. And we're happy to do that together with partners in other countries. So this sovereign aerospace is a big theme. We build every single part on our aircraft, every single mold, every single jig, every single tool. What we don't build is the engine, the avionics, although we do integrate those and customize them. And yeah, but the whole other part of the plane, we do ourselves under one roof. Now, we design it for cargo, but it's actually super useful for a lot of other applications. Let's say you want to do firefighting. You're not going to do firefighting with a Reaper drone, right? They were never designed for that mission. They were designed just to see, but they can't really do much about it. We can house, you know, hundreds of kilograms of fire suppressant, and we can drop it on the fire. From this point of view, it is a super cost-efficient system for the taxpayer, for the Volter's point of view. The same system you can use in good times and in bad. But what is the system? We call it the Black Swan. And it's essentially 350 kilograms of payload and a range of 2,500 kilometers. Now, you can play around with that. For example, on a firefighting mission, you're not traveling 2,500 kilometers, you're traveling nearby, so your payload is increased and so on. But the whole point is, instead of using, you know, big transport aircraft or big other aircraft, you're using a smaller pixel, right? We believe this is the right kind of pixel. We use gasoline, which, especially in Europe, was very unpopular, as you can imagine. But you know, the laws of physics don't care about viewpoints. You know, fossil fuels are still the prevailing technology to use energy across long distances. We use a very short runway, right? There's 50,000 plus that already exist. Less than 7% of them get any scheduled service. So there's plenty of real estate you can use. But you also don't need runways. You can land on 400 meters of unpaved space anywhere, which makes it very useful for contested logistics as well. Now, it was really not a very popular space. Europe was very happy to be buying non-European equipment. In fact, the US, being the pioneer, was the dominant and is the dominant player in that space of medium altitude, long endurance drones. Europe really never bothered to invest enough to get to the industrialization, mass production scale. So right now, when Europe needs to buy European, we're literally the only company you can come in with a bag of money and walk out with an actual drone. We've already built 4. We're doing flights. If you want to visit us in Bulgaria, we're very happy to show you. Now, Europe was happy to buy, and yet all the countries that happen to be building these big drones happen to be non-EU. So again, under a safe instrument and all these upcoming made in EU rules, it's tough luck for a lot of these companies. But even more so, again, these advantages that we have are focused on 3 main areas. Contested logistics is the obvious one. Whether it's civilian cargo or defense cargo, it's basically the same thing. You're solving similar problems. You're moving atoms across distance when the customer needs them immediately. Then the second big application is, as was mentioned, relates with our partnership with Hensoldt. So we're working with Hensoldt on a variant where we will be carrying airborne radars and essentially create an AWACS replacement. Now, with these radars, we can see ships at 370 kilometers away. We can see a Shahed at 50 kilometers away, 5 times more than you would see from a ground-based radar. When you're airborne, there's no blind spots, there's no limitations from the curvature of the earth or terrain. So it's a really, really great application. And that drone could literally be that drone wall that the politicians cryptically proclaim. Because if you can imagine a fleet that circles, the eastern flank or all of the EU borders, this fleet will be able to detect threats from very, very far away. Now, step 3 is you've detected them. Don't you want to do something about them? Of course. Now, big drones like Reaper and others, they can carry effectors, but they need to do them on the wings, right? They were never designed for a big fuselage, so they don't have space. We're working on, right, I'll skip ahead. Yeah. What we're working on is in the same fuselage, you could maybe house probably 100 to 200 small interceptors, and so when the Hensoldt drone, when the Hensoldt radar drone is able to see the swarm of 200 Shaheds coming your way, then its partner effector drone could launch 200 effectors against the threat and neutralize them before they've even entered your airspace. So this concept of tandem patrol, one spotter and one shooter, that is actually something that is very unique and differentiating. And existing, even non-European drones just simply do not have that capability because they were never designed for that. As a company, like I said, we've gotten from 0 to 1 on all these aspects. We know how to design, we know how to build, we know how to operate. Over the next 6 months, we'll be able to demonstrate each of these capabilities for customers and militaries from NATO and friendly countries. We'll be able to do first deliveries as early as next year. We're a team of 160 plus people from 20 plus nationalities. Most of us are in Bulgaria. It's a great place to build. We have the EU, UAE, and a number of other investors on the table, and we're raising a Series B round. Thank you.
Thank you, Svilen. And last but not least, last-minute addition to the panel, Aditya from DDrone. DDrone is a US counter-UAS company acquired in 2024 by Axon. So Aditya, please, the stage is yours.
All right, this is awesome. Going last is always fun when you've heard the same thing 50 times. So I want to get a kind of understand the audience here. Who's in a drone, counter drone, aerial defense company here? Raise of hands. 1, 2, 3. Anybody who's an investor in the space? 1, 2, 3, 4. Quite a few investors, okay. Ecosystem, big companies, primes. Okay, so like a good spread of folks. Okay. This should be easier. How do you go forward with this? Okay. So I have 8 to 9 minutes basically. I want to talk about the problem. Everyone's talked about the problem. I want to kind of hone in on a certain kind of specific example. Why is this a hard problem to solve? This is actually the important thing as to why there's so many companies trying to solve this, and it's still a pretty hard thing. The kind of approaches we took and the kind of approaches I think will work in the future. We at DDrone were more of we tried to leverage software, and now it's called machine learning, AI, if you will, to actually solve this problem at scale, and I'll talk about that. And then there's a lot we can do with the situation in Ukraine and how we kind of use that to protect the Western frontier, if you will, for democracies. This is a little bit about myself. Why should you listen to me? Because we are probably the only company that's actually exited in this space to all the investors here. We were acquired by Axon Enterprise, a $50 billion NASDAQ company, in 2024. We were doing counter-drone in 2017, 18, 19, when nobody talked about drones. So we were one of the OGs trying to solve this problem for a very long time. We took a very up and down route in terms of how we went about this. We solved the commercial problem first, which is actually the harder problem to do. How do you protect a stadium for $50,000 a year? And the learnings from there helped us deploy 700 sensors in Ukraine all along the border. So how we transitioned from that to the military, and now everybody's building for the military ever since the Ukraine war started. So very proud of what we've achieved. We're actually, my co-founders are German, so we have a 150% team in Kassel, Germany, north of Germany, small town. But we had to go global to become a real business for us to be able to actually build a business of scale. So this is the problem. This is a real thing. I was here in Kiev on a train back to Warsaw. So I was probably somewhere here when this happened that night. So you have about 60 locations all over, launching 20 to 30 Shaheds at one time. This is the real one-day solution. So 60 times 20, about 1,000 of these Shaheds flying in. You don't know where they're going because they're just meandering for a very long period of time. This is why the problem is really hard, because you don't know where they're going. And in the last 20 minutes, you know they're all hitting Kiev. And to just fake it, they hit another town here to confuse the system. So this is low-flying drones, Shaheds in this case, which you cannot see on a radar system if you don't tune it properly, flying in a huge, like 1,000 of them in one night, and then interspersed with maybe 20 expensive missiles which went and did the job. So this is what Ukrainians are seeing every night. Thousands of these. You probably have 3 or 4 interceptors that need to go in the other direction to intercept them. So you need 3,000 to 4,000 interceptors a night, which is basically the math. If you multiply that by 300 days in a year, you can imagine how much capacity you need in the system. Economics. Everyone talks about the economics. You've heard that those things cost $20,000. For the US DoD, the Tomahawks cost $4 million. I know Balas just walked in. There's companies like his that are building $20,000, $30,000 interceptors. There's some in Ukraine that are building cheaper. But this problem of attritable cheap drones is not going away anywhere. Detection and defeat is extremely hard because you cannot even detect where it is. I've seen the C2 that the Ukrainian soldiers look at. They generally know that there is something coming in that direction, and they're blindly shooting at night. And the scale of swarm that I just talked about. Again, why is this hard to solve? No one sensor sees all these. And again, you can have different types of radars. You can have different, different bands of radars. It's very hard to see all of them in one screen with one sensor. So keep that in mind. Flying patterns are unexpected. Somebody from MBDA was talking about a missile and how it's easy to kind of estimate a parabolic motion of a standard hypersonic. This is actually the value of a super expensive hypersonic in a $20,000 drone. Unbelievable. Sensor effective efficacy, I'll say this out loud as part of the industry. This is very poor right now. You take any interceptor in the world, even the best ones are maybe 20% efficacy. What does that mean? You launch 5 and 1 of them will hit it. So that plays into the whole economics of the game. And sorry. The last but not the least, electronic warfare. This is actually a massive game changer. There is a 100-kilometer area both ways, 50-50 on both ways, where people cannot maneuver. Nothing can move. So as a gentleman before me talked about, there is a huge area where there's just going to be robots flying up and down and maneuvering on the ground. And that creates a different dynamic in terms of how you locate these things and take them out. This was what we endeavored to do at D-Drone at a very high level. We wanted to build a broad sensor fusion and AI-based system that could look at. So we built a multi-sensor head that you could deploy every 3-4 kilometers. We put this on a trailer head, so you can move it around. You can put it on the back of a truck. And we've sold about 800 of these heads on different locations, different kind of configurations. And we found that all of them were networked into the cloud. Again, this is easy to say, but it just fails in EW environment. So we use Starlinks and the likes of it to get it into the same ecosystem. And then you prosecute. This is actually the hardest part to do. And I'll give you an example. This is where our system crashed the first time. So there were let's say 3 locations, 3 bases that were deployed all 30, 40, 50 kilometers away. And all 3 bases were seeing the 30, 40, 50 drones coming their way. So you eventually had a meltdown in the system because you had 30 times 40 permutations and combinations on how you could attack them, or how you could take them down. So people talk loosely about AI. I think it's going to be super important when you wanted to launch 600 of these and prosecute them. I'll go to the next page. Man in the loop versus on the loop. Fracticide. What's fracticide? It's basically you take out your own friend. You could have the best interceptor in the world. If it doesn't understand that there's a helicopter in the way, it will take out your own helicopter. Friend or foe. You have 800 drones flying, maybe 400 are yours. 300, half of them are yours. So if you look at Ukraine, they lose half the drones to just internal fight. Like they don't know what they're shooting at. So really, it's absolute chaos. And we as builders, startup ecosystem, investors, have a real opportunity to slow down a little bit, but think about how to solve this at scale. Because luckily for us, for Europeans and the US, less so for the US, Europeans, we still have a little bit of time. We can still learn from what's happening in Ukraine and Russia. And this is actually, the problem is at scale. You need to look at how to take out 1,000 of them coming at a city per night. How you do that is, luckily, we're in the age of AI. I think there's a lot we can kind of, understand from how to orchestrate these autonomous systems. And then you have your end-to-end systems, if you will. These are the how do I put it? There's an autonomy platform across the board, and there is endpoint solutions on how you take out the drones. So both these things are two separate worlds, if you will. And I think as investors, as company builders, and as ecosystem folks, we got to understand where we play in this, and that's probably how I would advise building a company in this space. I'll just leave you guys with something interesting as I think about how do you make this a sustainable company? How do you make this a sustainable field? Something that's not reliant on just today's battle, but 20, 30 years from now, I want all these companies to be sustainable. And there's a huge opportunity to take the battlefield robot data that Ukraine has and literally train real-world models on how you could actually do commercial applications. You could say this is pie in the sky, but it's not anymore. The greatness of Ukraine is they have incredible leadership at the top. Fedorov, who runs, was basically the defense minister now and the deputy prime minister, he opened up the entire database, data, multi-factor, multi-sensory data across the board, which could actually be used to train commercial real-world solutions. I don't know many people doing this right now, but it's something that I want to leave you guys with as companies and as kind of the ecosystem players, that this is probably how we make this a sustainable play in the long run. I'm here to have any conversation with anyone. Aditya Devarakonda, I go by AD. Thank you for your time, and any questions, please let me know. I'm just around the corner. Thank you.
Thank you, AD. I was tasked to leave you with some closing remarks. I actually hate those because it's very easy to get in some kind of patronizing mood and actually tell you what you need to think. I would actually prefer to leave you with a couple of remarks and actually echoing what our distinguished panelists mentioned during their presentations. And I think there are four that might be interesting for you. First of all, I believe personally that the counter-UAS market is criminally underrated in a sense of underfinanced. I believe it's a function of cost of overall unmanned systems market, which is easily valued above 40 billion annually. Right now, the counter-UAS costs in terms of budget allocations in different defense budgets across European stakeholders are it's just not enough. And I think you can see already the needle moving, both in terms of private capital and also state actors moving to change that. On the venture capital side, you can see companies like Cambridge Aerospace that are basically founded 18 months ago. They already signed the first contract with their home UK Ministry of Defence for a couple dozens of millions. And also, in terms of valuation, are already exceeding 1 billion, which tells you quite a lot where the money flows and how the market views the whole counter-UAS vertical and what are the opportunities in terms of exits, of course, that AD is a proud representative of. I think there is also a second thing about the state actors that are actually changing their opinion about the cost allocation. My home country, Poland, actually announced a program called SUN, and its overall cost of the whole system is north of 3.5 billion euros, and it's strictly dedicated only to air defense and also counter-UAS. I think that the second thing that was mentioned by our panelist was that Ukrainians are rightly so hailed as the best counter-UAS military. And they rightly boast an amazing number of kill rate in terms of shooting down aerial threats that is north of 90% right now. The thing is that even if it's close to 99, this number that is escaping them is actually the real cost of civilian infrastructure, their military sites, and also civilian deaths, which just shows that closing the cycle in terms of counter-UAS to have a fully functional kill chain that is actually trying to stop all threats at once is really hard to achieve, even in a wartime economy. And a third thing is that you can see how the iteration cycles and adoption cycles are shortening in terms of how the threats are evolving and how the counter measures need to basically have the same speed of adoption. When we are talking about Russian aerial threats, we can see that Shaheds or other platforms are basically increasing speed, payloads, and of course different tactics to oversaturate the incumbent defense systems that also AD was referring to. How the incumbent architecture of our air defense systems in Europe will pan out in a situation when we are overwhelmed by hundreds of threats at once, I don't know, but hopefully by the time it comes, we'll be ready. And finally, I think we need to understand how unmanned systems are changing the rules of the game on both ends. First and foremost, imagine if instead of shooting all of those platforms on Ukraine daily, and we are talking about hundreds that are targeting the civilian infrastructure alone, and we are not counting thousands of drones on the front lines. Just imagine how the potential for hybrid operations is increasing the moment where the Russian equipment is available for actions in Estonia, Lithuania, and Poland. When we are talking about drone incursions, when we are counting 5 to 10 drones, we are already shitting our pants. Sorry for my language, but actually we are basically already showing our huge gaps in our capabilities. And also in terms of changing the rules, unmanned systems completely changed the paradigm of air defense, and you can see that right now in Russia. Russia was always relying on the strategic depth of the country, and that some sites are just not accessible. Right now you can see that it's actually working against them. First of all, the technological development of strike platforms means that the range is not longer the case. And Ukrainians can fly to north of 2,000 kilometers with some platforms. And second of all, the size of the country means that their air defense system is spread out very thinly. And third of all, a prolonged war meant that Ukrainians had quite a lot of time to target all the incumbent radar infrastructure in Russia, and actually right now are capitalizing massively to target their infrastructure. So that would be my closing remarks. I will leave it with that. But I would like to thank again our distinguished panelists for the presentation, and I hope it was all very interesting for you. Thank you so much for your patience and your time, and see you around. Thank you.